Hey, good morning, guys. Welcome to the first class of CS2A this quarter. And in case you haven't been in my classes before, these classes that we have are really just like a face-to-face class, which means that it's like a technical meetup. So the cameras have to be switched on. So you can't go to a meetup with a mask on, right? So a social meetup, just like that. So it's going to be so make sure before you join class. On Tuesdays and Thursdays that you're in a safe place and you got reasonable control, so on and so forth. Yeah. I think we'll have a blast with this way because it'll be more social. People will know each other by face, be able to help. And here's a very interesting, I think maybe it's a theory, you can test it out. Yeah, maybe if some of you are doing double major in experimental psychology or something like that, maybe you could test it out. I think that in Zoom conferences, the probability of getting an answer or help from other participants in a meeting is demonstrably higher. I think if we can come up with a way to measure it, I think it's demonstrably higher for people that whose faces people can remember, right? Because I think that there is a measurable reduction in the propensity of people to help out or respond to questions that come from rectangles with names on it, okay? Unless the person actually, they know each other already. So please do, and so let's just make this whole class very collegial. Everybody knows everybody, able to help and all. So I think it'll be fun. Okay, so well, you know what, and I don't know if you've seen the previous classes that we've had, the previous lectures that we've recorded and posted before. So you should absolutely take a few moments. You don't have to watch them all, but I think that is roughly how we're going to do our quarter this. Hey, we got more students on. Yeah. Oh, okay. Because it's a minimum rectangle size or something like that. Or minimum icon size. It's not, Zoom is not showing all of you at the same time. All right. Well, yeah, I do have view gallery. Is there a way? I don't know if someone can tell me a way to shrink the, what do you call these little rectangular boxes in which you appear? So if you can shrink that, we can fit more people. I don't know if there's a way, but if you find, no, don't research it now. If you find out later, let me know. I'll do that. Because otherwise, later on, well, the first week, we're not going to do any coding this week, okay? Well, you're going to be doing coding, obviously, because you're going to be working on the quests. You can start already, okay? Because the first quest is very easy. You can start reading up the first module and submit the first quest. It's very easy. It's just to get your feet wet. And so you should be doing, but in class today and Thursday, we will not do any coding at all, okay? It's all about the fundamentals, okay? The basic stuff, and we'll do data representation. Well, mainly data representation, bits and bytes, how to manipulate bits and bytes, how to shuffle them around, what kinds of changes can happen, how to represent the data in the first place. Okay, those are the kinds of things. Now module number 0, okay, module 0, I believe I did link it into the, is module 0 linked into Canvas? I thought I had module 0 linked to it. Can someone tell me if it is? Yeah, Omar. Yeah, okay, good. Thank you, Omar. Okay, so module 0, it talks about data representation. And it seems like it's 18 pages and all, but honestly, I think it is very simple. In the sense that, it's just a lot of fluff in there, but not fluff to distract you, right? Fluff to just keep you engaged. Because I know sometimes when people start talking about data and some of these mathematical things, some people, not all of them, right? Who they tend to drift off, and they have to keep, re-anchoring themselves into. So when the going gets very mathematical. So what I've tried to do is just put a lot of fluff in, but people who are experienced and have a little bit more knowledge about data representation, not data structures, will be able to easily skip these parts and read only the meaningful and important parts. So get through that get through that in the next few days, okay? Because ideally you shouldn't be thinking about data representation at all. Well, you should be thinking about data representation, obviously. You shouldn't have to worry about it, right? Or, keep referring back. Well, obviously you can refer back, but you shouldn't be worrying about it past week 1. Meaning that all the data representation issues should basically be internalized at this stage, right? 2A, week 2 and later in CS2A, you shouldn't be data. You should know what a bit is, what a byte is, how bits are packed into bytes, how a byte can represent an English letter or a Chinese letter or a number, or even if it's a number, whether it's an integer number, which can't have fractions, or it can be a fractional number, okay, which can have fractional quantities in there. So those kinds of things. And how to represent a negative number, all of those things are covered in the data representation module. Now, it is important, I think, to cover and get a good mastery of data representation before you go on to real programming. I'm talking from experience, not just my own experience, but also the observed experiences of lots and lots, hundreds of students like you that have done these classes before. Okay, so you have a choice of doing things the hard way or the easy way. The hard way, unfortunately, seems to be the preferred path for many students, including myself when I was like you, right? When I was a student like you, I usually did the hard thing without knowing there was an easy way to do it. And the hard way is to not be familiar with the material that is going to be talked about in class, and thinking that, well, I'll attend class, that'll give me a rough overview of the topic, and then I'll read the material, the modules and everything, so I can put everything I learned in the lecture in the right places and get solid on the material. I believe, right, and you can even find evidence for this, I think, if you did experiments. This is the wrong way to learn at all, okay, especially challenging subjects, because what happens is that when you come to class without having prepped, right? Prep, when I say prep, doesn't mean that you have to read the material and already know everything before you come to class. That is wrong, okay? If you already know the material, why do you need to come to class? You don't need to come to class, okay? So the only reason for just reviewing the material really quickly and before class, even if it's one day before class or a few hours before class, that's okay, but it's important. Just flip through the material. This is what we're going to cover today. Why is it important? Because when you flip through the material, you'll see lots of stuff that you can easily understand, but you'll also see a lot of stuff that you don't easily understand. Now, when you're reviewing material before a class, it is important not to get stuck on the places where, oh my gosh, I don't understand this. How am I going to fare in the lecture? Because when they talk about this in the lecture, I'll be dumbfounded. No, you want to be like that, because if you get stuck saying, I'm going to understand this before I go on to the next page and I go to the lecture, then chances are you won't even get past this and be stuck there. But the whole idea of previewing the material before class is to know where the stumbling blocks are, know where the potential hurdles are, not actually cross the hurdles right there, right? Know where they are, so that when you come to the hurdle in a class, in the lecture, like we're talking right now, you already know, well, there's a hurdle coming up in 5 meters, so I can, start changing my gait right here. So I need to, pick up my pace so I can jump over it, or something like that, okay? Because you can't really be running at 50 miles an hour every minute of the race, yes? But however, you can run for 50 miles an hour. I don't know if it's 50 miles an hour. You can run really, really fast for short spurts. And you got to save these high energy bursts of your running for the places where these hurdles are. Now you only know, and obviously, and here's another thing, and maybe if some of you are music players, you'll probably recognize this, right? Knowing this is going to be hard, this is going to be hard, this place is going to be hard, just a few seconds before is really, really hard. Okay, when you come up to it, you only have very little time to prepare to leap over that, right? So the way to actually go through it seamlessly and smoothly and beautifully, and so that the flow is preserved and everybody gets a good experience, is to actually know, well, out there, there's going to be a difficult spot out there. There's going to be a difficult spot out there, okay? You just need to know the landscape, know the lay of the land before you enter. That's all, right? You don't need to master it, because in the lecture, what we'll do is basically sail through it like this. And when the hard part comes, that's you'll know, right? When the easy part comes, oh, well, there's a hard part going to come up there. So let me try and fit this in and see how it's going to lead into there. Okay, then you'll have a much easier time getting over the hard parts, and you'll find that that approach will actually help make work wonders. And regardless, not just computer science, whether you're doing math, especially in math, okay, especially because I told this so many times before to all my prior and previous students, especially in math. When I was a kid like you guys, okay, math, I would say, I would not read through the proofs before I go to math class. And I'd say, let me go to the math class and follow the math proof that the teacher is describing on the board. And obviously at some place, they're going to get stuck. Well, I'll get stuck and not be able to follow them. But that's the place I'll make a note in my notebook and I'll go home and review the proof again. That was a wrong approach, because what I do there is when I say I'm going to stop, I don't understand that, I'll review that later. That means that everything that comes after that has also been deferred for later. Even some stuff that might potentially be easy, that's been deferred. Okay, so you got a whole lot of stuff to catch up later, not just the few parts that you got stuck on. So, but by knowing the difficult parts, where the difficult parts are before you come to class, you'll be a lot. And I used to do that for math, and I said I'll do it later, and it never worked. Okay, and also like in exams, when you say when you read through a math proof, right, or a computer science, an algorithm, okay, so when you get to 2B or 2C, you'll be implementing some some not so obvious algorithms, some algorithms that actually work, but but they don't seem to work at all. You say, well, you have to actually prove that it works. You don't have to prove, but there are proofs that actually the actual algorithm actually works 100% every single time, but it's not obvious at all, right? So before the exam, you may think, even before an interview, an interview when you go out there and interview, or any challenging situation where you have to actually present, you might think that, well, let me go through my textbook or my modules and find all the difficult algorithms, and I'll understand how these work. Okay, now I think one of the things about these algorithms is that they are very misleading. Many of these algorithms, especially quicksort and all, right? It is very, very misleading, because when you read it, it seems it's very simple. Okay, you'll see, oh, that's how it works. I can follow the logic. It works, it works, it works. Okay, but the devil is always in the detail in computer science and math. We got to get down, because when I read through, I did this in the computer science when I was a kid like you and learning computer science. Not kid, right? I was in college and learning computer science. I did the same silly mistakes like I did in high school, right? Saying, well, computer science is not like probably easier than math, so I'm gonna just read through the algorithms before I go to the exams. But in the exam, I have to write out the code or something like that, and I find I can't do it. And I'm pretty sure that those of you who've done proofs or algorithms before would have had exactly the same experience when they have read through it and say, well, I know this, I know this, I know this, I'm going to ace the exam and come out, with flying colors. They go to the exam and they find they're stuck. Okay, and because even though they knew it, they didn't actually work through it. Now, it's only by working through it that you can recognize the nooks and crannies, which is where the real problems are. Okay, just like in real life, when you look at life from a bird's eye view, everything looks rosy, and it's very easy. I can navigate life. It's very easy. I just came into this world. I'm going to go and conquer the rest of the world. It looks like that. However, when you get into the detail, that's where you'll find, okay, well, I can go from here to there, obviously, because I can see the end point. But in order to go there, I need to navigate these treacherous courses, these nooks and crannies where there's hiding wild beasts and all, right? And so I need to make sure that I weave those details will only be apparent to you when you stop looking at, that's where I'm going to be anyway, because I can see it. I just need to go straight. Stop looking there and say, well, I need to get there. What or how can I get there? And then you'll start looking at the little details. And the little detail is where the learning also is, right? So the learning is not from learning, so this is how it works, okay? If you go to an interview and say, okay, and someone says, here's how do you sort this list, okay? And say, oh, I'll use quick sort, and it's going to, partition and do this and, divide and conquer. Yeah, okay, that's how it works. That's fine. And I say, all right, now implement it, okay? Now that's where the detail is. And when you implement quicksort, even though it's only 10 lines of code, it's only 10 lines of code, okay? Now in CS2A, you'll be writing programs that are probably 100 lines of code, 200 lines of code, even. Towards the end, I think the last quest you do is about 150 lines, right, of code. But when you get to some of the 2B and 2C quests, you'll find that some of the algorithms are really short. Write 10 lines, 15 lines of code. That's all you have to do. But those are actually harder to do than the 150-line programs that you wrote in CS2A, because you can understand the 10 lines in the entirety. But breaking it down and going in from step to step, you'll see, oh, I thought it was easy, but how did they get from here to there? Okay, that step seems to be a magic that happened in the professor's head or the programmer's head. Okay, so how do they do that? Actually, every single step is very well laid out, and there's simple things that you can convince yourself of and saying, well, that ought to work, that ought to work. Okay, that ought to work. These simple things are actually the learning points in any course. Okay, whether it is computer science, whether it's STEM or any other field. Also, these little things that most of the people that look at it from a distance miss, they don't learn. They know that this can happen if you get an expert in the field and get them to do it. And even if you go to companies, right? So someone who has a global view will say, well, I know this can get done, but I don't know how to do it. So I'm going to get people that know how to do these little things and get them to help me do it. Not do it for me, help me do it. And that is a mark of a successful CEO, because they know that this can be done, but they don't know how to do it. Yeah, because unsuccessful CEOs will say, well, I don't know if it can get done. I'll put a boatload of programmers on it and give them, tell them, do it, or you're going to get fired. Okay, that's the wrong way to do it, because nobody has any direction. They'll be doing their own shit, and eventually nothing happens, right? So you need to have a global picture saying that needs to get done, but at the same time, you need to be able to say, well, now that I know that it can be done, but I don't know the individual steps, I'm going to get some real experts in the field. Okay, and the experts will know how to do it. And pull them in and say, well, you can take care of this. You can take care of these UI issues because you're good at that. You're good at that. Okay. And you tell each person, this is the experience I want. This is the runtime efficiency I want. Right. And this is the network performance I want. And each of them, they know, right, how to do these things really, really well. And everybody knows that nobody is, everybody is indispensable as well as dispensable, meaning that, the whole team will get sunk if their part is missing. But at the same time, they know that, this is only one part, right? I can't do it without the other people, and the other people cannot do it without me. And that is a cohesive and well-knit team, and they'll do really kick-ass stuff later on. Okay, so I can see that most of you will probably end up like that in well-knit, close teams, creating kick-ass stuff. Okay, and the way to get there is just to start getting these deep technical bonds with each other, right? Technical bonds, okay? The social bonds, okay. You need to have a certain amount of social bonding too with your co-workers, but technical bonding goes one level deeper than social bonding. Okay, social bonding says, what do you like, what do you don't like, I'll try and not do what you don't like, and so on and so forth. I'll keep you happy, you keep me happy. Okay, yeah, okay, that makes for superficial relationships. But when you get to a really solid technical working relationships, you not only need to know what pisses off the other person, but you also need to know what their strengths are. Okay, what their strengths and weaknesses are on the technical side, and you only get that by working with them deeply, right, on some project. And then you say, well, that person can't do this well, but they can do this really well, right? It's important to know what they can do well as not they do well, right? Because lots of people seem to specialize in finding out what people cannot do well. Okay, so you shouldn't be that person. You should find out both what people cannot do as well as what they can do. The second part is harder. Okay, it is very, very easy to find out what people cannot do, because there's tons of things that you can do in the world, and so nobody can do everything. Yes. So obviously you can pick random stuff and say, hey, you can't do this, you can't do this, you can't climb Mount Everest, right? I can reel off a huge list of 5 million items that you cannot do, right? You can do the same thing for me too. Yes. What is hard, the difficult part, is finding out whether it is in a fellow programmer or a life partner or friends, whatever it is. The difficult part is finding out what they can do, right? Everybody can do really kick-ass and great stuff, but it has to be teased out sometimes. Many times, especially with students like you guys, I've found, is that the students themselves don't know, right? Students themselves don't know the level of greatness that they can achieve. How is that? I don't know, right? I believe that everybody can do really, really great stuff, but many people don't end up doing great stuff. Why? And it's because even though they have the potential, life intervenes. There's so many different factors. All of these conspire together, and only a small fraction of the people actually achieve the success that everybody is capable of doing. And there's lots of reasons why that happens. And most of the time I find, especially in the Bay Area, and I've said this to many 2A sections in the past, especially in the Bay Area, I think many students, and my own kids were also prey to this initially in many ways. The culture is that is one of seeking validation from outside, okay, and saying, well, if I do this, is this going to set me up to be great in other people's eyes, right? What is that person going to think of me? Is that person going to be impressed by me? Or all these people. So people are spending way too much time trying to impress other people. But at the end of the day, if you just relocated your mind into their heads, you'll find that what you do probably, even if you're really, really near and dear, right? You'll find that what you're doing probably occupies 10% of less of their mental cycles, right? So 10% of less or less of their mental cycles being concerned about you and your progress, but you think it is 99%. So you think that everybody else is thinking, I got to do this, I got to do this, and they push themselves hard. Sometimes they punish themselves hard, and all these nasty things happen because people are trying to live up to other people's expectations. And that is the reason why 90% of people's cylinders in their heads are firing, not for doing what they're really good at, because they're good at something and they don't know it. And they don't know it because they haven't gone looking for what am I good at. They're spending most of their time trying to find out, what do I need to be good at in order to please these other people. And so once we break out of that mindset, right, you got to break out of that mindset and say, well, you know what, the external world is out there, but it has its place. And however, what is important to me is what I do. And so if you focus on that and just use the external world as flavoring on your sandwich, not the meat of your sandwich, the meat, whatever, then I think we'll find that we can do a lot of really, really cool things. Yeah. So anyway, that's enough of a spiel. We'll talk about data representation today. And again, today, like most classes, we just have general free-form discussion amongst you guys. Oh, the guys who joined later, please switch on your cameras because I said this before and you may not have been here. Our classes are just like face-to-face classes and technical meetups out there. You can't go to a bar wearing a mask and say, hey, I want to be part of this social party, but I won't tell you who I am, right? It doesn't work like that. So and it's a class. I've never had a class that I taught face-to-face where people showed up with masks, right? So you got to be out there. And that is the way that people can also relate to you and talk to you and say, hey, let's try this out and so on. It's much more fun that way, I can tell you. Look at all the past videos, okay? Look at all the past videos. Well, our recordings of these videos that I post on YouTube, they're not getting a lot of hits. Well, you don't expect them to get a lot of hits because it's only usually the current batch of students. But if you look at the past ones, you'll see that of the hits this videos are getting, the ones that have the YouTube what is it? What is the splash screen? What do they call it? The icon, the thing that shows up before you play the video. Anyway, they have a name for it. Okay, some of them have lots of rectangular boxes with just names, but some of them have pictures of students' faces. Okay, and you can see that
the thumbnail.
Thumbnail. Thank you, Antonio. Right. Yeah, thumbnails. The ones that have people's faces on them, they get a lot more views from other students saying, there's something interesting going on there, because otherwise people generally don't. And that's the other reason too, that you need to, in our classes, what you're saying, everything you do here, think of it as a way of preserving good memories of you into the future for your descendants, right? Many generations down, you're not even alive, right? Who knows, right? So think of it as a way in which you're preserving good memories for you to, and to look back on and and say, hey, that was really cool. I did that, right? And I was, and again, this is the other thing I think to keep in mind. Being clever, especially in programming, is less value than being helpful, kind, and beautiful and compassionate to other people, because those are the things that you look back in 50 years and say, well, I knew that, but I knew a lot more, because a lot more than what I described in that video to my classmate, because if that was the only thing I knew, I wouldn't be describing it so nicely. Well, I don't know. Some people have this mentality, right? But But if you describe it in a really, really nice way, you'll know that, well, you know what, this, I probably knew a lot more than that, because I'm trying to get that person to learn more, right? I want them to understand what they are struggling with, but also lead them into the next problem, which is going to be juicier, which means I also know the solution to that problem. Okay, so those are the kinds of thoughts that you will, you can, you know, you'll be nice, you'll be happy to look at and say, well, you know, that was really cool. So those are things that you can focus on. So yeah, this is a portfolio. And by the way, also, and since you're 2A students, and hopefully if you're going to carry on all the way 2A, 2B, and 2C, this is your great chance to develop a portfolio of, you know, just your name. Someone should be able to go to Google or a search engine and type in, right, you know, Hana Hassan or something like that, and they get a bunch of links. And hey, YouTube videos in which Hana was there. Hey, Reddit posts. Check out these Reddit posts. You know, she made these really, really interesting posts here on some very subtle artifacts in this algorithm, right? And those are the kinds of things that good hiring managers will look for eventually. Or even if, you know, it's going to be, or even if you're going to be hiring other people, okay, later on, you start your own company and you say, you know, I'm going to get a recruiter to get me some top candidates to work in my company, okay? And they look you up and say, well, I'm going to be working for Antonio here, and let me Google and find out what kind of a boss he's going to be, right? And they look at all the helpful posts that he's made to fellow classmates before, right? All the top coders will just be, you know, getting in a line to work for him, right? I want to have that experience working with Antonio, right? Because that kind of mindset is what I want in a manager. This is a good manager. So so set yourself up for in a path to success by already starting to build, you know, any other course you these days, especially since, you know, I think especially university education in many ways is starting to take the backseat, you know, because today communication, information, everything is so free, easy to share. Everything is out there. If I want to know about someone, I don't need to look at their university transcripts anymore. I don't need to know where they went to school, whether it's a top school or something like that, right? All I need to know is I just look at what they've done, and everything is out there. And that gives me a greater picture, 360 view, right, of the candidate than any resume I can read about them. Because the resume at the end of the day, all said and done, is 2 pages. You know, if it's more than 2 pages, most people won't read it. Okay, so back and forth, you know, just 1 page or 2 pages, that's all a resume can contain. So what you want to build is a portfolio, because if you go to art or movies, right, making something, you know, creative works, and they want to look at a portfolio and say, hey, wait, give me a folder of all the things you've done so I can flip through it and see if anything just strikes my fancy, right? And this is your chance to build that portfolio starting right away. And you'll find that you'll have lots and lots of opportunities in 2B and 2C to make these really, really nice posts, observations about interesting problems. And I'll toss out a lot of interesting problems along the way too. So you can noodle on these and post your own thoughts. It is okay to be wrong. Okay, that's another thing that many kids these days. This way, fortunately, this was not something that affected me when I was a kid. But in addition to all the problems that I faced, like, you know, I have to please other people and all, this new problem seems to be today in today's kids that I've seen is the fear of being wrong. Okay, because when I was a kid, even in class, when the teacher asked a question, I would say, you know, that's the answer, and it'd be totally wrong, right? Even wrong to the level that it demonstrates that my thinking was fundamentally flawed in a, you know. But the teacher wouldn't laugh. Many of my teachers didn't laugh, or they weren't unkind to me. They basically say, you know, go and, you know, no, you need to brush up on this before you go and tackle that problem. Okay, and so you get that kind of feedback. But today, many students seem to think that it's a taboo to be wrong. No, it is actually a great sign of strength to be wrong. Only strong people will dare to be wrong in public, right? Because if you're a weakling, you won't try to be wrong. You'll say, well, you know, I can't do that because, you know, what if I'm wrong? Those are signs of weak people, right? So dare to be wrong. Who cares? I don't care, right? And you shouldn't care either, because, you know, even if you're wrong, it doesn't mean you're wrong for life, right? It's not a life sentence. He said, I was wrong, but I was wrong 5 days ago, but I'm not wrong anymore because I know the right way to do things now. Yes. And so that is the person I want to employ. Well, I'm not hiring anymore, but that's the kind of people that people want to employ. People that are not afraid to be wrong and then be corrected, because that kind of person you can fit into any team. Right. So it doesn't matter. I'm not a sports guy. I don't watch games, but I'm told by people who are coaches, when my kids were in school, I used to, even though I didn't know any sports, I signed up and I was a coach for their baseball team, little league. And I don't know if I was a good coach and all, but certainly what I found by talking to other coaches was that the good people to place in a team are not the rock star players who always hit home runs, who always, strong players. No, those are not the good people. The good people are to get in your team are the ones who can listen to the coach and say, well, you know what, even though you can do that move really well, you'd be much better in this position than that position, because here that move will, give you more bang for the buck, or something like that. I don't know what that move is, because I don't know if such a move exists in sports, but coaches are looking for people who would be able to recognize and understand that something they do is not right, but they're willing to change it or go to a different place and try something else that the coach suggests, rather than be defensive and say, no, you're wrong, you don't know enough, and I know better, right? And correcting all the fellow students saying that's that. So that kind of person is harder to manage in a team, because you have a team of many different people and you say, well, these teams are responsible for these things, and someone says, no, I'm not going to do this the way that everybody else tells me to do. I'm going to do it my way because it's better. It is harder to manage those people. Okay, so those kinds of things that people that don't have any worries being wrong don't care about. And being wrong is a great virtue and an asset. Okay, if you're wrong in public, and also say, hey, you know what, that's fine, thank you for telling me this. Okay, that is a sign to a hiring manager saying, well, at least that person, I know for sure that person knows it, because they didn't know it and now they know it, right? If they didn't know it, they would say it. And but if someone if someone was never mistaken in public, and I have no idea if they really know something, they say they know, right? So those are qualities to watch out for and improve. One thing that came out, I need to make sure before we actually start launching into the, before we launch into the actual, class discussions, is that, someone posted recently about tip sheet. How was it, Antonio? In 2A, someone posted something about a tip sheet, right? Or maybe it was 2B or 2C, I don't know. Okay, so I was talking to my 2C students yesterday. We had a meeting, and an idea occurred, and I'm going to trial this idea this quarter, and probably for all quarters going forward until I retire in a couple of, no more, all right, no more points for tip sheets. Okay, so that means that someone who's completed a quest and writing a summary saying these are tips, and these are the ways and places you can get stuck. Here's where you need to be careful. Here's where you need to be careful, and so on and so forth. Yeah, okay, there's a ton of those online. Okay, well, online or even on the Reddit. For every quest, you have tip sheets, but they're not going to be valuable for points, participation points anymore. The reason is that first, last quarter, I said, I thought, well, students are not really pondering these problems and solving them on their own anymore. They're just looking at the past tip sheets and solving these problems and moving on. I don't know if they learned the material at the end of the day. Right. So I said in the last quarter syllabus, no more looking at past Reddit posts. I don't know if it does. It still says that in this syllabus, right? No more looking at past Reddit posts. You got to imagine that the Reddit did not exist until the class started. You can only talk to current classmates. But even then, so that worked better. That worked better than before, because people were talking to each other, not looking at the past. But there were still some students, right? Not all. Now, still some students who when there are these quests to be completed, who would potentially lag behind the stronger students, not because they are weaker or things like that, but because they're waiting for the stronger students to complete a quest and publish a tip sheet on Reddit, so that they can, because according to the syllabus, you cannot only look at the past posts, you can look at a tip sheet published by a current student. And so they look at the tip sheet and say, all right, I'm going to do all those, and then they pass the quest without actually understanding what's going on. Okay, so I'm going to say from this quarter onwards, no more points for tip sheets. Please don't publish tip sheets. However, publish musings, interesting things, right? And it shouldn't cover the entire quest, ideally. So you pick a couple of things, a couple of places where you got stuck, right? Or maybe even one place where you got stuck in the quest, and say, well, here's where I got stuck, and this is what the misunderstanding, and I fixed that, and I moved through, and it was cool. Okay, just one. So that people just don't get one post from Reddit and say, okay, tonight I'm going to solve quest number 9. Okay, here's a post by Angela on quest number 9. I'm going to go and solve exactly, do everything that Angela says. All right, no point in doing that. So you can post musings, interesting things. You look at the 2C now, right? The 2C Red subreddit now. You'll actually see some examples, because some of these are starting to emerge now. People are not posting solutions to quests anymore, but they are posting interesting things they observe in the process of working towards a solution, which is so much cooler, isn't it? It's so much cooler, because now it's actually this is starting to take shape these days. Over the last year, I think, my Netflix and Prime and entertainment watching has substantially dwindled. And I was thinking, well, I didn't make a conscious decision to start watching less Netflix. I didn't make a conscious decision to do less entertainment-oriented stuff. Why is it? It's because I find that I'm spending more time just looking for Reddit posts in our subreddits, right? Saying, hey, are there interesting posts in the green or red subreddit now? Because some of them are really juicy and interesting, okay? And they keep me occupied for a half hour of thinking, right? Half hour is as long as a sitcom. And it gives me more pleasure than a sitcom, right? Because because it exposes the deep thinking inside of a student's head, which most professors don't get a chance to observe, right? Because even in the past, when students used to code up these solutions and submit them, I'd print them out. Well, I didn't print them out. They were in PDF. I had this thing on an iPad, and I would mark the PDF with the red ink and get them back to the students in their hands after a week of submission or something like that. But even then, I found, what was I saying? I don't know, I lost my train of thought there. But basically, I think, you should essentially just feel free to talk and build up your portfolio and answer questions and expose your compassionately knowledgeable side. Okay, I think that's a better way to put it. Compassionately knowledgeable side. Everybody has a knowledgeable side. Okay, but wise people, I think, have a compassionately knowledgeable side. So they have knowledge, so they're also willing to share. And the reason for that is because knowledge is only fun when it is shared. Lots of people don't seem to realize that, okay? Because if you have knowledge and you're only going to use knowledge for your own well-being, you'll reach a limit at some point, okay? You say, well, $500,000 a year, I'm happy enough. My knowledge is giving me $500,000, and with that, I can have what I want, okay? And you can be happy. But, is that the limit? That's all you're going to be? No, there's something even deeper and better than that. And that's where you need to go. Right, and that you can get only by sharing the knowledge and saying, well, who else would like to learn this, and then together maybe something might blossom and say, well, you know what, I tried to teach this to you, and in the process you taught me something else, and together we can make that. That kind of thing blossoms, and so I will look forward to seeing lots of those. And anyone who's completed quest number 9 at any time this quarter, I'm happy to engage in some kind of a extracurricular project. Okay, I didn't think it'll work for 2A. Is my camera on, by the way? I'm not on screen, so I can't tell. Because it'll be bad manners. Hang on. Where am I? Oh, I'm on the next page. Oh, I am on the next page already. Okay, this is the first page. Oh, here I am. Okay, all right. So yeah. Anyway, I don't know what was I saying. If you have any questions, obviously ask me. Otherwise, what we can do is today, and we can start off today by people having a free-form discussion about data representation. Now, even if you don't know anything about data, meaning that you didn't get a chance to read through the module 0, follow the discussion along, read the module 0 today and tomorrow, and Thursday, again, we'll have a discussion. on data representation. It's a class discussion. I'm not going to participate. I'll just be a bystander, okay? But you can yank me in and say, hey, Prof, can you come back? We were talking about this and nobody knows how to solve this. Can you help? Well, I'll come back and I'll help. You know, what's a big deal, right? But ideally, you guys should all be helping yourself. And also try to, yeah, I don't know, you'll find a good way, a balance of keeping everything in check so that you can all talk to each other and guide each other. So today, talk about data representation. What are the things in data representation? You know, ASCII, binary, just binary. Oh yeah, converting from one base to another. Yeah, oh, here's the thing that you should probably try and do. Convert your name to base 26, right? If you, do you know how to do it? All right, raise your hand if you know how to convert your name to base 26, I think. No, from base 26 to decimal or hexadecimal. How many of you know about converting from one base to another? Right, so all right, some of you know, right? Some of you haven't read module 0 yet. That's what we talk about in the first part of the module. So it's very easy, very, very easy. Okay, but all the same, there's some intricacies that you may not understand, especially converting from decimal to binary or something like that. Okay, so you can bring that up, and we can do that on screen, or someone who has an iPad or a tablet, they can share the screen. Usually, I think you can run Zoom on an iPad and share the Zoom screen, and with a pencil you can draw. Yeah, you can draw on the iPad, and that will also be shared. So you can actually work through like a notebook, some of these problems. And later on, from next week onwards, we'll be doing coding like that, right? One of you will be coding. I'll be walking you through the code, talking you through the code, and you take turns coding, and we'll create cool stuff, you know, with C++ in the class. And I think it'll be fun. Okay, so today that's what we're going to do. Is everybody happy so far? That's what we want to do. We want to be talking about data representation. If you don't know anything, that's fine. Just follow along. People will be asking questions. Other people will be helping these people. Just follow along. This is going to be recorded. You can watch it again, but don't bank on the recording. Okay, you should follow along in class. And you can ask questions too, and saying, hey, I'm trying to understand converting from base 2 to base 16, all right, or vice versa. What are these bases? How can I add two binary numbers? What is the 2's complement? Okay, that is something that many people get stuck on, and hopefully, if nobody understands, well, I'm sure lots of people will understand this. We can definitely have a couple of examples worked in class. Okay, either today or on Thursday, we can work through some examples in class. I can explain 2's complement in many, many different ways. Okay, starting from, you know, this is how 2's complement would look if it was just decimal numbers that we're used to in everyday life. And if you want to do something like 2's complement using base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? How do you do this? And what is the point of doing 2's complement? Why does it help? And so on. Those are interesting points, right? Interesting points with very ingenious solutions, right? That is the reason why, yeah, right? Even in 2A, 2B and 2C, students will find lots and lots of ingenious things, right? Ingenious things that programmers before you have done, okay? Great people have done incredibly cool things, and they will be taught in 2B and 2C. Right, and when you're doing those, you will stop for I think it is impossible not to stop and marvel when you get an aha moment. Okay, when you get an aha moment when you're doing 2B and 2C, you may be fighting with something for a long time, saying, "How is this even possible? How is it even possible?" Go to bed thinking that's impossible. That's impossible. You wake up in the morning, take another look, and say, "Wow, that is how it's possible." Okay, I never saw that in 15 years of my life, and that's how it's possible. Okay, and that is an aha moment. And there's 2B and 2C quests littered with lots of them, right? You will never find these aha moments if you look at a tip sheet and just implement everything that everybody says this is what you're going to do, right? Instead, if you just fight with it and say, you know, I'm close to death, but I'm still going to keep trying to solve it. But the next day you discover you're not dead and you also solved it. That gives you this incredible feeling. Okay, there's lots of these, but even in 2A, right? 2B and 2C, there are lots. Even in 2A, there are these aha moments. For example, take 2's complement. Okay, many people don't know what 2's complement is, but even after you understand 2's complement, there is an aha moment buried in there, and saying, why is 2's complement done this way? Right? What is the point? Why? Right? And knowing why, maybe it won't. It'll take a week, a couple of weeks. Maybe that won't even happen when you're looking at the screen or looking at the modules. Maybe it'll happen when you're biking through a park. Okay. Wow, that is why 2's complement is done that way, right? That is what you're going for. So every time when we run into these problems, you're basically setting yourself up for an incredible treat. later on, right? Maybe not immediately, but you're basically setting it. So take away these problems where you're facing a dead end, a brick wall, okay? And don't toss them, but you got to keep them in your mind somewhere, because that is a brick wall you're going to demolish someday. And you'll feel really happy when you do that, I think, right? So that's what we're going to do. So next week we'll start coding simple programs. All right. Obviously, by next week, most of you will already know about Hello World, because you would have done quest number 1, which is very simple. Okay, quest number 1, and done that. But progressing on from that, we'll do more and more interesting. Hopefully, I don't know. Right? I'm just saying these off the top of my head. But I think we'll do more and more interesting and useful things. Interesting things. Maybe not useful, but certainly we'll do a lot more interesting things going forward in class. Okay, I think this is going to be a great section, because I see a lot of eager to learn faces on screen, so this is going to be fantastic. Okay, if you just maintain the class dynamics like this, and be friends with each other, this will be great. Okay, and I don't want to go back to my 10 years from, I haven't been teaching. No, I've been teaching for exactly 10 years. No, it'll be 10 years when I retire. 8 years now. No, it's 9 years maybe. Okay, so I don't want to go back like 5 years to how I taught these things, where I forgot what I forgot what was unpleasant that time. I knew I didn't want to do that again. That's why this new system is working better. I wanted to say what it was, and I forgot what it was. Okay, but anyway, I think this new way of doing things will actually and greatly help. We'll be doing lots of interesting code. Yeah. What I remember now, right? Back in the day when I used to teach, when I first came in here and started teaching, the attitudes of many students were, even though students were equally capable, equally, knowledgeable, all these things, nothing has changed. People haven't evolved all of a sudden in brain cycles between, 5 years and now, right? It's all, the people are the same. Students have the same amount of abilities as before, but I think the mindset was very different in my prior classes from 5 years ago, meaning that the students, even though they knew something, they wanted to be the only people knowing that. They wouldn't teach this to other people. And it was very competitive, saying that, because if I get an A, if that person gets an A, I'm not going to get an A because it's a curve and it's all, balanced out and things like that. That is a total load of shit. Okay, I don't buy into that. If you're good, you need to get an A. I don't care if the entire class gets an A, right? So my grading standard is absolute in that sense, saying that if you demonstrate the knowledge, you get an A. So I'm not going to curve things to make sure that, some proportion of class gets an A. If it comes out to be a bell curve, naturally, that's okay, right? Because, life intervenes and not everyone will have the same level of opportunity to work on something at the same time, right? So there will be a bell curve, but I'm not going to force it on you by saying, well, everybody did well, but I got to deflate some. No, right? So everybody can get an A in this class just by doing cool stuff, which means, and that has actually worked wonders in my past classes. Go to the videos and look at the Reddit forums. You'll see there's a different culture, completely different culture in my class, right? The students actually love each other, right? Students respect each other, love each other, and they're out there trying to help other people, right? Which I've never seen this. I haven't seen this, in the first 5 years. Well, there were some students, but here recently, it's turning out to be so much better. Okay, maybe you're even a role model for all classes everywhere in the world. Okay, this is how a class should be, right? And I say, look at these students, and this is how you should be. And it's possible. It's possible that a professor at Harvard could say, well, you've all struggled really hard to get here, jump through hoops, but now that we're in this class, we know that you're all capable and strong because only a small fraction can get in here. But at the same time, this is how I'd like this class to be. Look at this class from Foothill College. Okay. And they put a YouTube video on screen. All right. And say, that's the kind of class that we want in this class, not a class of all really, really wise guys knowing how to do things. No, we want a class of really compassionate wise guys who know how to do things and be able to share the knowledge too. Okay. Because that is the only way anyone can make something bigger than themselves. Okay, if you're keeping all the knowledge to yourself, you can only make something that is as good as yourself. If you want to make something bigger than yourself, you got to take something bigger than you. They say, I got all my stuff, but I also want all the other good stuff. So let's just all get together, right? Everybody working together is where how good stuff gets made. All right, enough of hand wavy spiel. We should get into more rigorous stuff in computer science. So I will actually leave it at that. Well, how long did I talk? Oh my gosh, it's what time is it? 8:51. Wow, that's almost an hour. Okay, so you got a whole hour, possibly more, because it's raining. You're not going anywhere. Okay, it's supposed to be a thunderstorm. Where's the thunder? Where's the thunder? All right. Okay, so you guys should feel free to talk for the rest of the hour. Also, leading into Thursday and the Reddit forums, start making posts on the Reddit, as soon as possible, talking about interesting observations and stuff like that. And you'll have a great time. All right. I'm very happy to see you all and a decent showing in class. Right. Many times I've gone into a class where 9 or 10 students show up. Okay. And it's okay. I don't have a big problem with that because I'm just going to teach what I can teach. But I just feel at the end of the day saying, well, you know what, it would have been so much nicer if instead of 9 students, there were 90 students, right? Because so many more people would have learned this, which means the chances are greater that some number of them will come together and build something bigger. Yeah. So I think that I can see that here. So that's fantastic. Okay. All right. So if you have any questions for me, I'm happy to answer them. Otherwise, I'm just going to hand it over to you guys. In fact, what I can do is what I usually do is so when I hand it over to you guys for a conversation amongst yourself, I will turn the laptop around so that I'm not in your face, right? In fact, I'll try not to listen to you, but I'll be on like Alexa mode, right? What I mean by Alexa mode is that I won't be listening to everything you say, but I will be scanning for one keyword, professor or Anand or something like that. So when I hear that, I'll come back here and say, hey, I heard my name, what's going on? And I can help you. But otherwise, you just feel free to talk about, anything you want. This is going to be recorded, so you're not going to be doing, saying stupid stuff and all, which could potentially, endanger your own life. Don't give out personal information. But other than that, you just feel free to talk and have a great time. People should look at this video and say, I want to have a great time like that, like the Meg Ryan in that movie. I don't know what that movie is, Harry Met Sally or something like that. Okay, there's a scene in that. You can Google that, Harry Met Sally, Meg Ryan scene. Okay, and then there's someone else saying, I want to have what she's having. Okay, so people should look at this video and say, I want to be in a class like this class. Okay, and make it like that. There's nothing wrong, right? And what I mean is, it's not impossible. It's not impossible. You have it in you, and I think you can make that happen. And I'm going to be here. Okay, I'm going to be here. Hey, someone had a question. Someone said chat. By the way, don't use chat. Please don't use chat, because the chat message on Zoom just comes up on my screen, stays for a few seconds, and then disappears. And unless I click on the chat icon and go in there, which obscures a part of the screen and all, right? So just interrupt me and say, hey, prof, stop right there. Shut up and listen to my question, right? So you can actually say that to me. I don't have a problem. Okay. So quick question, is the Reddit post a requirement or just extra credit? Because I don't see. Hian. Where's Hian? Hian? Oh yeah, there we go. Yeah. Reddit posts are necessary for participation points, essential for participation points. Okay. So which means that you can, if you read the syllabus, you'll see this. You can pass the course, you can pass the class, this class, without having to participate on Reddit at all. Okay, you can do all the quests, you can do really well in the midterm and the final, you'll get a B+. And if you ace all of them, B+. If you're happy with a B+, that's fine. But if you want to go from B+ to A territory, you got to put yourself out there. Okay, that's putting yourself out there is the only way to get the participation points. So so you got to say, I'm going to go to Reddit and look at what problems other people are having, so I can offer a tip saying, well, you know what, I was in a similar situation, I tried this and it worked, can you try that? Okay, and you'll also develop this incredibly, I think it's a difficult skill. Okay, it's a difficult skill, and maybe that's why got to be, maybe teachers can, maybe it's easy for teachers. Okay, because just through experience, it's difficult to not give the answer and just point a person at where they can find the answer. Okay, and I think it's difficult because I don't know why it's difficult. Okay, I don't want to speculate here, but that's what it seems to be, right? It's easier for people to just give the answer outright and say, this is what you need to do, right? This is where the problem is. Look, rather than saying, well, did you check that? Did you check this? Because, in order to do that, these things need to be in place. Did you make sure that those are okay? That is what you'll be doing for your entire career in computer science. And it's not as dry as a biscuit like that, okay? Even though you're saying these things, it'll actually be really interesting and fun. And so you'll develop a skill. You'll develop the skill of not giving out the answer, but actually nudging people in the right way. Now, this skill, and I know this because I've been teacher and a manager and all these things in past lives. Okay, so this skill is not just useful for being a teacher or teaching other people. This is an incredibly useful skill if you want to manage other people, right? Managing products and inanimate stuff is different. I'm not talking about that. If you want to manage humans, right, it's a different ball game altogether. A manager of humans needs to have this incredibly useful skill, being able to point the user, but point the employee at the solution, not telling them what the solution is, so that that person will both be able to find the solution themselves and feel good about it, right? And also know that they're not beholden to the manager by saying, I'm just going to do what the manager tells me, right? Because if you hire someone and they do everything you tell them to do, that is, instantly that person is good at what they're doing, but they're not going to get promoted. Okay, because in order to get promoted, you need to go beyond that and say, well, I'm not just good at doing this, but I can, I can step beyond that and help other people. Then the manager will know, all right, good. So now I've got someone else who can take my place and I can do something else, because that person can now come here and guide other people, because you want people to let other people find their successes, right? If a manager just is interested in their own success, it's going to be a very limited success. Okay, the company is maybe going to make a couple $1 million and that's going to stagnate there, right? But if a manager is interested in saying, well, this is really cool and I can help lots of other people succeed also using this, that product is bound to be a killer. Okay, everybody would love that. eBay and all these other people, Amazon. In fact, I think this is true of Amazon, because Amazon originally was a company that only sold its own products. Okay, but I think there was an early employee at Amazon who came up with this idea, saying, well, if you only sell your own products, maybe you can make a few $100 million. Okay, but we don't want to be a company just makes $100 billion, $100 million. We want to make billions and billions of dollars and be really big at it. Okay, then that means you cannot just make and sell your own products. You got to position other people to succeed and take a share of their products and profit, because taking a share in a nice way, saying, I don't want your entire profit, but I made the success possible for you, so I'm going to take a 2% cut or 15% cut or whatever it is, what the calculus dictates. So when they decided to do that, Amazon just took off. I don't know, you should probably look at case studies, but I think maybe this is how they took off. And I said, from all of a sudden, they went from being a 100 million company to being a billions of dollar company, because they made it possible for other people to make money, other people to succeed. And so that is a mark of a good manager. Okay, a good manager lets other people succeed, and then the other people's success will be your success, because nobody will, if you help someone succeed, they're not going to take all the success and go away. Right? People will take varying degrees of the success, depending on how much they feel entitled to it, but you'll always get some share of it. So the more people you help succeed, you're going to get a little bit of share, and all of that will cumulatively add up to being a lot more than what you could have got yourself. So so that is the trick. That is a trick to being to developing a good product, developing a good company, developing good morale in a company, and lots of happy and good employees, is to just make sure that success is shared. And which may mean that sometimes you may have to make the hard decision of letting go of people who aren't contributing to the success, but also draining other people's success, right? This is so those are things you'll also be able to identify really quickly and say, well, you know what? In order for the company to succeed, I don't need these 10,000 employees. Half of them don't even know what the hell they're doing, and they're just entitled. They feel entitled and mooching on what they get from other people, right? Those people can go home, right? But these remaining people, they're actually doing some kick-ass stuff, right? And they're trying to help the other people do kick-ass stuff, but they're not doing it. right? So those are the people you want to keep. And how will you identify these people? You can only identify these people if you've been one of them yourself. Yes. If you've never been one, you can never identify them. So this is a way you can learn to identify strong people, really strong people that you want to work with later on in life, by developing this, cultivating this tendency in ourselves. Everybody has this tendency, right? As humans, we all want to work with other people, right? Sometimes certain, I think, malignant cultural tendencies, right, which tend to creep up, tend to taint these natural tendencies that we have in us to say, well, you know what, if you do this, you're screwed. Don't do it, right? Even though that might actually be a good thing to do. And but naturally, everybody has that tendency to learn more, to share more, to have fun together with other people. Everybody has that, but it's just being sidelined because of the toxic culture, potentially toxic. I don't know if it is out there like that today, but potentially toxic culture saying, no, those are bad qualities. Don't bring them out there, right? You just need to go succeed and step over other people and get to the top. That's the only way you can get to the top. Yeah. Boring. It's a boring success, right? Going, so these are qualities you can try to nurture, right? Like everything, it's like neurons in the brain, things need to get nurtured in order to get better and bigger. And so the growth mindset, saying I need to learn, rather than saying, well, if it's difficult, I'm not even going to try it, because if I try it, I'll fail. That's the other thing, right? Many students feel is that I don't want to try something new, because the risk is that I might fail. I might damage my own opinion of me, saying I thought I was omnipotent. I could do everything in the world, but I just discovered something I couldn't do. So I can't live with that image of myself. Some people feel that, okay? So they won't do that. That is not the growth mindset, right? So growth mindset will say, you know what? Yeah, I don't care. Even if I don't do it, what the hell? You know, I just failed, but I tried it. Okay, so I'll go and try doing that. So that growth mindset is there in everybody, because if you see kids, children, they don't care two hoots about what they try are going to fail or not. I don't know, right? You watch a kid brother and sister, they try lots and lots of things, right? They don't know if it's going to work. They'll try it anyway. But as they get older, I think somehow the tendency seems to seep in, saying, well, don't try things that you're not sure it'll work, right? And I think it's all probably related to saying, well, if I try something that didn't work, I lose the good impression that these people have of me, right? Because you're trying to impress other people, and that tends to stifle the growth mentality, growth mindset, and saying that, well, you know what, I don't need to learn anymore. I just need to do what I already know how to do. I need to do that in a more ostentatious way, so that more people can see what I can do well. Okay, that is the wrong thing to do. And but that is what tends to give positive reinforcement to kudos from society. So if that is what it is, well, the best thing you can do is just withdraw from society, or withdraw from the toxic elements of the society, right? Withdraw from the toxic elements, just reduce your social circle to just the healthy people, just the interesting, healthy, knowledgeable, and compassionate people. You know, it's not going to be like hundreds of people anymore. It'll be like 5 or 10 people, but those 5 or 10 people will be really good. And that's the kind of clique you want to form. And so the growth mindset needs to be cultivated like that. And when you cultivate it, like, you know, we're watering a plant, and that will take root. Once it takes root, and that's what you'll find yourself doing naturally without having to do it consciously, right? Growth mindset, helping other people, enjoying success with other people, all of those are there in every single human, right? But they're just not expressed because of outside forces. Let them out, right? They need to be expressed, because that is the route to happiness and happy success, rather than unhappy success, right? Unhappy success at the end of the day does not matter at all, right? But a happy success will totally matter. And that's where these skills, no matter whether it's computer science or any other field you go into, this will actually, you know, stay with you all the way through. All right. Okay. All right. So who wants to do, unless you have any other questions, I just want to turn the laptop around at this point. You guys can have a conversation of your own, and the conversation can go along the lines of someone who started working on binary conversion, okay, or adding numbers, or, you know, or even not knowing what binary is, saying, hey, can someone explain what binary is, right? And someone else jumps in and tries to explain. Any point, if you feel that an explanation is taking 5 minutes or longer, you can say, well, you know what, let's call the prof, okay? And I'm happy to come back here. I'm just going to be here, right behind somewhere in the next room, maybe I can hear you, okay? I will come back and walk you through any particular problem you're stuck on, right? And make sure that everybody is okay and following along. Is that okay with you guys? Is that a good modality? Because I mean, I can only do this for this class and next class because I think when we start coding, I need to be present all the way through. Yeah, when we start coding next week on, I won't be able to take off like this, right? Give you time to talk on your own. You might have to organize your own meetings for that. Because when we start coding, we'll be coding all the way to the end of class. And it'll be fun, right? Everybody will be following and everybody will be coding and calling out code and so on. It'll be fun. We'll be doing it. But I won't be able to give you time on your own like this, right? Only today and Thursday, I can give you like this in 30-minute blocks or 45-minute blocks when you guys can just talk amongst yourself. Maybe we'll come up with opportunities for doing this later on too, but take advantage of today and Thursday to do that and talk about these things. You can talk even if someone can, if you've never, if you don't have anything to talk about, you can pick up module 0 right now, right? And read the first few pages and say, well, you know what, here I was reading this and this is kind of confusing. Can someone explain this better? Okay, someone else. And also when people are explaining, give everybody a chance, right? If you've explained something already and someone else is volunteering to explain something else, let them go first before you try, okay? And all these things, but these are things that won't come naturally on day one, right? So you'll find yourself stepping over each other's toes for the first few meetings, but gradually you'll see that this kind of thing is automatically self-balancing, okay? You'll subconsciously just pick up the skills. And these are skills that will serve you really, really well in group meetings later on, right? When you have a technical meeting with your boss, right? And lots of people are in the room and you have overhead screen showing, you know, these charts and so on. These skills will really come in useful, saying, well, this is how we can do it together, and just by asking questions and drilling down into the data. Yeah, because in all these high power meetings that you'll have later on in your career, you'll find that the really, really high power meeting, the top meeting, the core meetings, nobody is interested in personalities at that point. Okay, when the meeting starts, people pretty much forget faces and names. Okay, they only see what's on the screen and the ideas that are bubbling up into the air. They even stop recognizing the voices, right? They're looking at the screen, someone shouts an idea. I've had this happen to me. Okay, looking at the screen, someone shouts an idea. This is a really cool idea. You're not even looking. You know, you're curious to know who shouted the idea out, right? Because it's a really cool idea, but you don't even want to waste the time to look behind and say, you know, because that idea is so catchy and it's grabbed you and say, that's really cool, right? That means we can do this, and it's like, yes, it just solves something really cool, right? And so you're more enamored by the idea that faces, names, personalities, all of that out the window. Nobody cares a shit about those things anymore. All they care about is this really cool product that is just morphing to shape in people's minds, and they're all in sync because it's all pretty much the same product, right? Everybody's vision is now aligned to come together. So now people don't have to think about individual visions anymore, right? So you can say, hey, this is the whole thing. This is Adrian's idea. This is Michael's idea, right? No, those are not, you know, because you're all part of the core team now. And nobody looks at individual ideas. They're all looking at the whole product, okay? And that is a fantastic feeling, right? You all need to be part of that. You will be, or maybe you already are, you know, who knows, right? So, but it is a great feeling to be part of that and see something great. And I think the reason why I think it's great, again, speculation, is that we're seeing something that is bigger than ourselves come about, right? Bigger than ourselves, meaning, you know, I couldn't have done this myself. And nobody here could have done this by themselves, but it happened because all of this came together. And you know already, right? You can't just get you can't just throw lots and lots of characters, ASCII character letters, English letters, and get a Shakespearean play, right? In fact, there is a famous question in philosophy, right? You just give a monkey a typewriter, and the monkey just punches random keys, and you have an infinite universe, right? Infinite time, and infinite time will eventually produce Romeo and Juliet, right? By just typing random keys. That's an interesting philosophical question. And so yeah, so it never happens. So you can throw a lot of brilliant minds in the same room, but the central idea may not come to fruition because they're all out of sync. They're all firing in different directions. right? In order for something really, really cool to materialize, you need to take really, really powerful engines, put them all in the same place, but also make sure that, now nudge all the engines, right? Make them all fire in the same direction, slowly, gradually, without making them lose power, right? That's the job of a manager, right? You can't force someone to do something against their will. They'll do it, but it won't be full power, right? Because that's not what they want to do. So the manager's job is to figure out what can I get them to do so that they'll still do it with the same level of intensity as if it was their own task, right? That's something, right? And that is why it is important not to give the solution out or not to direct people to do, this is what you got to do. You're saying, this is a problem, how would you solve it? Then they go about solving it in their own way. And many times, if there's brilliant people, they come up with really cool solutions. That's the way these things happen, is not just by getting all the brilliant people together. So you're all brilliant. But coming together alone is not enough to create something bigger than yourself. Coming together and waiting takes time, right? For things to align, and that is, balance out and the resonance to happen. Okay, when it happens, it just blooms right in front of your eyes. Okay, this thing, and you'll see, well, that happened, and I couldn't have done it. Nobody could have done it, but that happened. Okay, and that is a great feeling to have too. So you'll have a great time that way. Okay, any other questions? Otherwise, let's do the usual thing. I'm going to turn the laptop around so that you guys I'm not in your face, and you guys can talk. Is that okay? Yeah. And if you don't have questions, pick up module 0 right now. And the first few pages, try to understand it. If you don't understand something, you can say, hey, anyone else who understands this, can you explain this to me? Right? And so on. And I think it'll be fun. Yeah. Nobody's well, Omar is nodding his head, but nobody else seems to. Oh, Omar, is so and so not 100%? You don't want to. You're good. All right. So is everybody else okay with just brainstorming amongst yourself? I'm going to be there in the background, right? Is everybody okay with brainstorming? And again, switch on all your cameras, okay? You can't. This is like a real class. You can't just come to class and not be behind a screen. So this is like if I was teaching in class on a whiteboard, everybody has to have their cameras on. So please, are you guys okay? Please raise your hand if you're okay with that. Otherwise, I won't feel comfortable turning the laptop around and disappearing. Yeah, good. Musa, Justin, Antonio, Mingwa, you good? You good? Mingwa, okay? Yeah, good. All right, James Kwan, right? All right, Mohammed, Megumi, okay, Hao Ming, okay, Nam, I can't see you. Sabrina, you good? Yeah, it looks like everybody's okay. Hey, Ruzi, you good too? Hey, by the way, I noticed, maybe it was Ruzi. No, I think it was Ruzi. Reddit. You got to make sure your Reddit username follows the spec outlined in the spec. Okay, so it has to be like, for example, let's say Karthik wants to make a Reddit username. His Reddit username should be something like Karthik_P12345. Yeah, so that someone who replies to a post that he makes will say, hey, Karthik. Can't say, right? So it's better to, and when you make a post referring to answering someone else's question, try and be personal and say, hey, Karthik, hey, Sabrina, right? And so on and so forth. Use names as much as possible. And names have to be in that format. User names have to be in that format, because that's how my algorithm can pick up and assign points later on. Well, strictly speaking, I'm not even using my algorithm these days, because I don't have a huge number of students. I actually look at the post. Like I said before, these times, even when I'm sitting out there by the orchard sometimes, I'm feeling bored, I just go to my phone and look to see if there's any interesting posts on the Reddits, right? On our Reddits, not even random Reddits, okay? On our Reddits. And that usually keeps me occupied for a long time. And I come out feeling really good after that, right? So, so make these, and so what I mean, where I was going with that is that I don't need an algorithm to find who to give points to, but if you have names in this format, it'll be easier for me to assign points at the end of the day when it comes to the final grading time. I know, right? Oh, that's Karthik P, so that's the Karthik, right? Is it JK, right? So I know that's J and so on. Rather than, so some people have, things like coding girl or something like that. How do I know? There's so many coding girls. So how do I know who to give points to at the end of the day? Yeah. So you need to be that way. It'll help me greatly. All right. Thank you all. Thank you all. I think I've touched base with almost all of you now. Everybody's okay. And so have at it, okay? Enjoy yourself. This class is meant to be enjoyed because it's a skill you're going to be picking up. It's a skill you're going to be picking up. It's better to enjoy yourself picking up the skill because the skill can be used in enjoyable ways later on. So only when you learn to enjoy the skill as you're learning it, you'll be able to enjoy it after you learn it, right? If you learn it saying, well, I'm not enjoying it right now, but this will set me up to make a lot of money with which I can enjoy life, that will not take you there. I can guarantee, okay? The only way to enjoy things is to actually learn it, enjoy it while you're learning. All right, thank you all so much. Just call out to me. Call out to me if you need my input on anything. Otherwise, I'll see you on Thursday and I'll see you on Reddit, okay? I'll see you guys on Reddit in the meanwhile, but I'll see you on screen, obviously on Thursday also. And then we'll take data representation to a little deeper on Thursday. We'll work through some examples maybe. Because at that time, some of you will have questions, floating point representation and so on. We'll work through some examples and set ourselves up properly for, coding starting next class. All right. Okay. So there you go. Good, good week to you guys. Well, this is Tuesday, not even the start of the week. All right. Enjoy. And it shouldn't be silent, okay? Someone should be talking because if it's silent, someone who tunes into the video might say there's nothing going on and they'll go away. So just be talking. It doesn't always have to be about the topic. If there's total silence, just start talking about a movie too. Doesn't matter. As long as there's voice, someone will come in. And if there's silence, nobody wants to break the silence. Here's an observation I've made in the past is that if there's silence, everybody is very reluctant to break the silence. But if someone is talking about trivia, right, movies or the weather, there's no problem, okay? People don't have any problem interrupting someone who's talking about the weather because they know, and it's not offensive to do that, right? When someone's talking about, when there's silence, however, people are reticent. So try and avoid that.
Has anybody seen the menu?
Heard it was really good.
Really good. Really trippy, but really good.
Yeah, pretty all right.
Yeah, so has anybody actually read the first module about data representation? Like all the way through? I read through like a third of it.
Read
and
half of it.
like, how stuff is represented in computers with numbers, and I think it was like ASCII. You read about that? How like you use numbers 0 through 10 to represent like every letter in English. And I kind of read through that, and I got to the part where you got the binary, where instead of having like 10 keys, you only have 2, like 0 and 1. And then it kind of went over my head. It was a lot to take in. I don't know, like anyone like super into that and able to break it down.
I've found personally that the easiest way to understand binary is like, we think of numbers as just, it's powers of 10 for each decimal, whereas binary is just powers of 2. So if it's the third number, then it's going to be 2 to the third power, 2 to the third power.
So I see this whiteboard feature that I kind of want to try. I'm just gonna click it, see.
Try it, yeah.
So I guess we can all draw on this.
I'm gonna try a little bit. Let's see. Oh, cool. This is gonna be so useful.
Yeah. Is there something that somebody wants to talk about
like
or
a
draw out?
whiteboard.
Yeah, I can try to explain that binary code. I think I got that a little bit good. Let's see. So the numbers that we play with every day, I call them normal numbers, but they are called decimals, right? And I noted that it's just a form just like binary, like hexadecimal and octal, which are other forms we're going to learn later on in the as you keep reading. Decimals is named after the deck part, at least. It's for 10 because we read these numbers as powers to 10. So I forget the example they show in the page, but let's take a number like 1762. I'm just making this up. Now we see it clearly as like, okay, this is broken down as 2 1s, 6 10s, 7. Sorry, did I say that wrong? 10. Yeah, 6 10s, 7 100s. So that's 7 times 100, and 1 1000. And that's going by, if I write this down, 1, then 10, then 100, then 1000. So this is going by tens. So this is how I started to learn about binary. When it comes to binary, we have it, instead of going by tens, that's 1, 10, 100, or into 1000, it goes by 2. So you start with 1, then it goes to 2, then 4, then 8, 16, 32, and so on. That's how I started understanding binary code. So once you started seeing like random like string of numbers like this, I'm making this up too, I don't know if this is gonna work, then I start to, now I'm getting stuck. But I'm trying to, and thank you for was it Matt that wrote that, the
Yeah.
2 yeah, thank you, that's easier to understand, that 2 to the 0, 2 to the 1, 2 to the 2, that's such as, and I'm gonna write it for the tens here if you want to understand the numbers we face with every day. 10 to the 0, 10 to the 1, 10 to the 2. Thank you for adding that.
You got the right idea going, Omar. It's the same thing. You can just take the 2 to the power of here and your 1, 2, 4, 8, 16, 32, and just place it right below the binary number. So for example, on the very right side here, this would just be 1.
Right.
And this is going to be, you know, there's no 2s, no 4s. This is going to be an 8. And then no 16s. This will be a 32, 64. And then I have horrible handwriting, but then you just add them all up and that's your number.
Thank you for reminding me that. Yes. Did you get that part of, was it Justice who asked a question?
Yeah. Okay, yeah, that makes more sense.
Yes.
Like having it in front of me, that's useful.
Fantastic. Yeah, I hope it does help. And then it's the similar idea with, you're going to learn more, you're going to learn about the octal versions, which goes by 8s instead of 2s, and then hexadecimal, which is 16s instead of the 2s here.
That
Yeah.
binary number that you wrote would translate to the 643281, or
Will translate to, yeah.
translate
So
to
Yeah.
decimal?
No, I think it would be the sum of these, right?
the sum of those,
Yeah,
yeah. So
Be all of them added together.
32 plus
Oh,
8.
okay.
So the first number we got on the right, and I go from right to left, is 1. And yes, you would add and then we have 0 2s, and then 0 4s, and then 1 8. So I'm writing that down. So if I bring down the zeros too, then you'll just see plus 0, but I'm kind of ignoring those. And then you keep going. There's 132. I'm sorry, that's go. And there's 164. And then you add those. And I guess it comes out to 105. Is that right?
Yeah.
I think so.
I didn't write that, but yeah, it looks like,
Yeah.
and that will be the
Yeah.
number. So yeah, this code of binary on top turns out to be 105.
Oh, that makes so much sense. I wish I listened to you before the data representation assignment.
And I think technically too, we don't need this 0 if we're writing binary. I don't know if there's
That's
a certain
right.
amount of like numbers you need. But
Nope, I figured out through all my reading that any zeros on the left you could just disregard. Yeah, I like double check that sometimes too, and turns out, yeah, you could just ignore the any zeros to the left.
I guess I'll share something that I thought was pretty cool in the reading. So it was the multiplying by 2. I'll just do the example right here real quick. Or somebody else can do something else while I write this out.
Yeah, keep going, yes.
1101.
I'm just completing this list of wordings. Octal is, you would see, is 8, hexadecimal is 16.
It's kind of hard writing with a trackpad.
Oh, track that, yeah.
Actually, let me
Oh.
try 01.
Mhm.
10. Yeah, it's just the same in decimals to add a 10. It's just the zeros in the end.
Wait, is that what it is? You just added a 0 on the right side?
Yeah, so you
Yeah.
add a 0 here, and then you like shift everything over whenever you multiply by a factor of 2. So
Mm.
so 0. Let me do this in a different color.
Oh, I see it. Okay.
If you think of it, it's the same as, you know, if you just have a standard decimal number and you multiply it by 10, you add a 0. Whereas if you multiply a
Right.
binary by a power of 2, you can add a 0.
Oh,
And
I
I'm
like that connection.
assuming it's going to be the same for octal. And then hexadecimal is a little bit interesting just because it adds some letters into it. But
That's right.
And then if you like multiply by would it be 6 to shift over
8.
8? It would be
I think
8.
it's 8. Can be 6.
Actually, hexadecimal would be the same as well. If you're multiplying by a power of 16, then it would also be a 0.
Mhm.
So when you multiply by 8, so you would add another 0 and everything would just shift over.
Interesting.
Yeah, I thought that was pretty cool. And then yeah, for hex, I guess if you multiply by 6 every factor of 16,
Mhm.
I mean it makes sense because it's everything's base 2, so you're kind of like doubling up here. And so yeah, everything just shifts over.
Cool.
That makes sense. I feel like hearing it clicks better than reading sometimes.
Is anybody more knowledgeable about hexadecimals?
I think there's one important thing I can give you about hexadecimals. That is that there's that little chart in
Yes.
the reading,
Page 14.
page 14. Yeah, correct. That one. And just as how it says that once you want to put a value of 10, that would be A, 11 would be B, 12 would be C. And you would just, once you know how to read it like that, just simply then it should feel the same as to binary and and all the other numbers, only you're dealing with bigger numbers.
Okay.
Now, did you want to bring an example or have another question with that?
Sure. Let's try and do a number. Can I erase some of this stuff up here?
Of course. Yeah.
Also, I had something random to say about hexadecimal. I used to like I was kind of particular about like graphics and colors. So with stuff like you can eat, so I knew before that you could everything is a hex code. But I didn't really know what it meant. So I just knew it was this combination of letters and numbers, and didn't know the background behind it. So now I need to actually go back and I guess, yeah, like see how maybe if I can go back to binary and how that actually matches up with the actual colors. So cool thing. Look up the hexes of the colors that you want, and I guess see like what the correlation might be with like the words and the binary and the numbers. Now it's a whole nother world for me, I guess.
Me too, 100%. I was, I'm all into graphic design too. And when I looked at I didn't realize the hex code was short for hexadecimal. And then I recognizing the letters and the numbers together, I'm like, oh my gosh, that's what the colors are based on.
Yes. No,
Yeah.
I knew it was I don't know. I knew it was short for hexadecimal, but I didn't realize it was the 16 base of binary. So now it's actually means a lot more than it used to. Just I don't know. Saw it's a random combination. So that's a fun fact, friends.
Yeah, I actually attempted to take one of the colors, like a random green, and try to like turn it into a decimal number, a normal number. And it's huge. It came out to like 11 million or something. And I'm like, oh gosh, no wonder we use these codes to do that. It's amazing.
Yeah, no, I was kind of realized that when I tried my name. My name has a Z in it. So that was fun, turning that into numbers, because I was like, we're
yeah.
doing it on my iPhone calculator, and I'm like, this is a mistake. But it was a fun assignment.
Very fun.
So from what I can tell, it's the same for like big numbers like this. It's just divide by 16, grab the remainder, divide by 16, grab the remainder, divide by 16, grab
Yes.
the remainder.
Yes. I can even show an example if anybody else is curious. Exactly what you said. I'm gonna take a number 2, 4, 3, 1. And if we're gonna do like how it shows on the paper, but dividing by 16, right? I end up with, and let me do it on my calculator so I can see here, 2431 divided by 16. I get 151.9375. What I like to do, and anyone correct me if there's a faster way, is round it down to the whole number. Always round down, 15. And then to determine the remainder, it's not as simple as binary code where it's always 1 or 0. This one, I just take the number 151, I clear my calculator, 151, and then multiply it by 16, almost going backwards. I end up with 2416, and then subtract that from the previous number, 2431. So 2431 minus 2416, I end up with the remainder. I typed it wrong, 2431. End up with a remainder of 15. I'll put R15 here. And I can explain that again because I know I'm not writing all of it down, but I keep going. And then 151 divided by 16 again. Let me write 16 here again. 151 divided by 16 gives me 9.43. So I'm rounding to 9. And then taking that 9 and multiply by 16 to figure out the remainder. And I end up with 144. So 151 minus 144. I end up with 7, a remainder of 7 here. I keep going, divide by 16. This time it's 0 with a remainder of 9 because 9 is left. And there's your hex code. If you go backwards, you have 9, 7, and then 15. But we know by the chart that 15 is represented by, I think, F, if I'm correct. Yeah. And when you write hex codes, I don't know why, but you have to begin it with 0x, if I'm correct. So it will look like this, 0x97f.
Okay.
Let me know if you want clarification, because
No, yeah, that makes sense.
yes.
I'm just gonna figure out what color that is.
And the cool thing is you can convert this to binary very easily. So binary or so like each hex is actually like 4 binary digits. So 9 would be 1 0 0 1.
Mhm.
And then 7 would be 0 1 1 1.
And f being
F
15.
is 4 ones.
And is that it, just together, or do you have to?
Yeah, it's together. So I
No.
just kind of separate it out because so like each hex digit is represented by 4 binary.
That's right.
I think it's called a nibble. It's 4
Mm.
bits.
Yeah, that was the reason why it was easier to go between binary and hexa, because for the nibble, which is half a bit, is like then from there it's easy to kind of go back and forth.
Nice.
And then this, like if you go back to like decimal, like this would be 15. Which is, you know, what you got right here, and then this would be 7, and then this is the 9 that you got
Mhm.
right there.
Nice.
And then one thing I remembered from the notes too is that like with this whole transfer process, right? You can think of a byte as a combination of two double-digit hexadecimals. So if that one was like one hexadecimal digit longer, that you have a whole byte, or no, so it's two digits, right? Because 4 is half a byte, so that 8 is 1 byte, so it's like a byte and a half, right?
Mm.
Yeah, 4, these 2 would be a byte.
Mm. It's like trying to
Would they be a
think of
byte or a bit?
bit.
Mm.
A bit is the
Uh,
symbol. A
A
byte
bit
is
is
4.
just one number, but a byte is H.
Got it, got it.
One of these is called I think it's like a nimble or nibble.
Yeah, nibble.
Nibble,
Nibble,
like a bite,
nibble.
nibble.
Yeah, four bits is a nibble, which is half a byte. A byte is 8 bits. So out of that one, each 1 0 is a bit. So that one, the ones and zeros are bits. The groups of 4 are the nibbles and half a bytes, and then 2 groups is a byte. So that's a byte and a half
Mhm.
of data information.
I guess one of the later ones is base 27. Which I'm assuming is pretty similar, but
I guess I still don't fully understand like how we represent the positive and the negative. I know there's the 1 and 2.
That I'm confused about too.
Positive, negative, we just use the first digit. For example, if we have, for example, 1 byte, that's 0, 0, 1, 0, 0, 0. This is 1 byte. And if it's unsigned in C++, that this will be always positive. But if it's assigned, that the easiest way to do that is we use the first digit to represent positive or negative. This is I think 0 is negative or
Positive.
positive. Is it positive? Okay.
Yeah.
So if it's 0, it will be a positive, and we only use these 7 digits to represent the number. So if it's as a result, if it's a digit assigned variable, that's the range is smaller than the unsigned, since there's 1 digit that's used to represent positive or negative.
But we have 2 zeros here, so like how do you know if like the binary starts like just this part? Or are these two just like placeholders there?
What do you mean by 2 zeros? You mean these 2?
Yeah.
We just use the fixed first digit to represent positive.
Well, so I think what he's saying is, because typically if we're writing a binary number, we wouldn't need this whole section there, because it's 2 extra zeros. So are they just placeholders to make it a full byte?
So can you write it as 1 0 0 1 0? Is that the same, or this would be different? It's just removing these 2 zeros.
It can when we write the numbers on the paper, we can just write in 6 digits. But if we store in a computer, for example, if we have an int, that will have fixed, I think 4 bytes.
Okay, so it's always going to
So
be
the digit is fixed.
yeah.
Yeah.
So it's always a multiple of 4.
Or
multiple.
I think it's the 4. Why? Well, it's too hard to write here. If we int or unsigned int. We'll always have 4. This is fixed, so we can quickly know what is the first digit.
I just looked up positive versus negative real quick, just to kind of get an idea. So the 4, for example, like this is 12 in binary. If you add a 0 here, this is still 12, but this is just marking that it's positive. Whereas if we did 12 and then added a 1, this is still 12, but then this is marking that it's negative.
Negative, yeah.
So if there's an extraneous, these two right here, you know, it's not part of a group of 4, which we would typically use as a nibble. That will designate the positive or negative.
Oh. Yeah, so yeah, my question was like, how do you know if you count that, for example, the left to 1 as a number or as a positive or negative? And I think you just explained it, that if it's,
Yeah,
you know, if it's like outside of the 4, for example, like a byte, then you can assume
So
it's
I-
being used.
I think in proper binary, we're supposed to write 2 like this instead of just writing, you know, that.
Right.
Oh, that's why the zeros matter. I see.
Yeah. So it's, I think it's always about the groups of 4 and the nibbles. That's from what I gathered in a quick Google search though, so take it with a grain of salt.
So that means you wouldn't ever write it like that, right? It would.
Yeah, you don't want to do it like that.
But even in this one where it's a group of 4 and then we have the 1, if we wrote them all with the zeros, wouldn't it be like 3 zeros in front of here? Anyways, I'm not good at this. I'm sorry.
Oh, yes.
For which one?
I just, what did the one you wrote on the bottom? Someone wrote on the bottom.
Yeah, so for that, you just focus on the group of 4. So if you're writing just, you know, if there's 5 numbers,
Yeah.
then you're expecting, okay, whoever put this down knows what they're doing and wrote that group of 4 as the number, and then the 1 designates the 1 or the 0 as the 5th number, designates the positive or negative. You wouldn't assume that there would be 3 more zeros.
Okay.
But this could also be like another number, because if you interpret this as, you know, the group of 8, this is this one would probably be a 32.
12 plus 16.
Or this is 0, 2, 4, 8. This would be a 16, and then you could, you know, you could think of this
So-
as a number.
Yeah, so this number would be 28. And then if I wanted to make it negative, I would do that.
And yeah, the way I see it is like, okay, now you have a number that's outside the 4 or the standard 4 to the standard 8.
Right.
And that's what makes me think, okay, they're using that to indicate if it's positive or negative. That's what I'm getting from this. Hold on, I need to reread something just in case.
Can we store the number with some digits as outside the standard 8?
That's what I was going to
So-
look at too. Actually, let me draw.
I think
this.
in my knowledge that the variable is fixed digits with fixed digits. That's always 8 or 16 or
Right.
yeah. So we can quickly know the first digit. So in this example, this will be ignored, and we can quickly know this 0 to be the sign. That's what I know.
So yeah, I think I know what you're talking about. It kind of showed in the reading as well that there may be instances where you can only have a maximum of 8 digits. So people would use that first square to use as the indicator positive or negative, and then the next 7 digits for the actual value or number.
So then how do we know? How do we determine, you know,
I
what's...
thought it was the leftmost number is the sign.
Yeah, but it could also be part of the number in this case.
Maybe it depends on the context. Maybe you just know depending on the project you're on or whatever it is. But I don't know if somebody maybe has a better answer than that. Oops, didn't mean to draw that. Yeah, I remember them mentioning that with all 8 squares, if you used all that for numbers, you have something like 256 possibilities of what is it, numbers combinations. But with only the 7, you're giving up that first squared for that positive or negative sign, and now you only have 120 something. Was it 126 or
27.
20? Thank you, 127 possibilities. So like we gave up that to have that extra square for to indicate the positive or negative value. I think that's what I read. So that was interesting. Need to look back and reread.
Uh, excuse me, like if you are trying to figure out how this working for, like you can just Google the IEEE floating point. Like it's the whole stuff about how the like calculates how you can calculate the number. Yeah, it's kind of like that. I send the link to the chat box, like you can check it.
Thank you.
To go.
Did we get out at 9:50?
I think so. So I have another class that I need to get to, so I'm gonna log off.
See y'all next time.
Okay, see you next time.
See you guys.
Thank you
Yeah,
guys.
later.
Made it really
See
easy.
see you
Yeah.
next time.
Great, thanks, Sam.
Bye. See you next time.
Professor?
Yeah, hey, you guys done? You guys done, or you have a question for me, or
I think we're done.
Yeah.
you good? You good? Yeah, was it fun? Was it fun? Getting together?
Yeah.
Awesome,
Very helpful.
awesome. All right, okay, that's great. Yeah, well, here's Peter. Yeah, you can feel free to leave. I can where is it? Bye. Let's go.
Great. Thank you, Professor.
Hey, no worries. I'll see you guys on Thursday. Okay.
See you Thursday. Bye,
Yeah,
guys.
Thursday.
Bye.
I had a question. If so I'm at UCSB and I have
Sorry, I'm sorry, I
in-person-
missed the last part. You said something.
Oh yeah. I'm at UCSB and I have an in-person lab that's from like 8 to 11, and on Thursday, and I was wondering if I could still like succeed in this class if I like watch the YouTube video for your
Yeah,
lecture instead.
provided you only miss the Thursdays, and you have to make up for that by participating a bit extra in the Reddit.
Okay.
Yeah, and make sure you attend all the Tuesday lectures and help out like you've been doing. So
Okay.
that's great. Yeah, no worries. See, the thing is that all of the rules I have in place in the syllabus, including grinding, bursting, all of these rules, they're only there for me to help, for me to catch slackers. So people who are good students, active and learning stuff, they get a lot of lax. They can
Right.
do whatever they want.
Okay, sick, perfect. Thank you. Appreciate it.
All right, see you later.